Look at the sheer scale of this illuminated digital grid, pulsing and connecting to distant satellites. We rarely build isolated software applications anymore. Instead, we engineer massively intertwined entities, global financial networks, cloud-native infrastructures, and intelligent city grids. As the scale of these interconnected environments grows, our ability to communicate about them breaks down. A chief financial officer, a lead engineer, and an external auditor can look at the exact same infrastructure and see entirely contradictory things. These conflicting perspectives generate friction. When teams operate with fragmented mental models of how a system works, they make localized decisions that clash. The result is compounding technical debt, operational misunderstandings, and cascading failures. If the people building, funding, and regulating a complex system cannot align on what that system actually is, they lose the ability to control its evolution. To fix this, organizations typically draft a sprawling technical diagram and assume that the drawing itself is the architecture. The ISO IEC IEEE 42010-2022 standard rejects that idea. As you can see in this conceptual visualization, it separates the top layer, an abstract floating web of glowing nodes, from the flat document blueprint below. The standard makes a strict distinction. True architecture is strictly intangible, consisting only of concepts, properties, and governing principles. Notice how the top abstract web continues to pulse and operate dynamically on its own. This invisible architecture exists inherently in the real world. The rules and behaviors governing a system operate independently, regardless of whether they are documented on paper or trapped inside an engineer's head. When we actively map a system, we see these solid vertical lines striking downward from the floating nodes, locking into the layout below. This illustrates the rigorous engineering act of capturing and translating those invisible rules for human understanding. Managing modern complexity requires a universal methodology to extract those intangible rules and organize them into a structured, communicative format. This is why the 2022 update to the standard expanded its focus from systems to universally broad entities of interest, or EOIs. Because an entity is no longer strictly defined as software or hardware, we can now architect an enterprise governance model, a business strategy, or a data structure using the exact same logic. To document these entities, the standard introduces the architecture description, or AD. This is the intentionally designed tangible artifact, the actual physical or digital models and records used to express the entity. By applying this rigor to non-technical concepts, businesses can ensure their underlying organizational logic is as visible and as auditable as the software they run. The AD aligns fractured teams by taking a single source of truth and organizing it into customized viewpoints, each tailored to address the specific concerns of different stakeholders. Here, a central 3D wireframe splits into two distinct 2D projection planes. On one side, we see a financial bar chart mapping cost flows for a CFO. On the other, a technical logic tree showing data pipelines for an engineer. They look different, but they accurately represent the exact same underlying architecture. No architecture exists in a vacuum. These incoming arrows represent multidimensional environmental pressures, legal scales, technological gears, and economic constraints that constantly press inward on the entity. Watch as the legal compliance icon pulses, causing the wireframe to shift and restructure its internal geometry. External forces, like sudden GDPR data regulations or technological disruptions, force the entity's architecture to adapt or break. The standard makes it clear that the universally perfect architecture does not exist. There is only an optimal architecture for a specific, heavily documented set of environmental constraints. By mapping these constraints within the architecture description, architects ensure the system doesn't just launch, it survives real-world chaos. There is a myth that an architecture description is a finalized document that is abandoned once a product goes live. In practice, the AD allows architects to model trade-offs before they are implemented. By adjusting parameters within the AD, they can see exactly how a security upgrade impacts system latency or total operational cost. It also serves as the definitive roadmap for safely transitioning away from legacy systems. detailing how to migrate data without causing operational downtime. Furthermore, the AD acts as a technical standard in vendor acquisitions or external contracts, providing a clear boundary against technical ambiguity. This makes the AD a tool for driving daily executive, operational, and financial decisions throughout the entity's entire lifecycle. Adopting ISO 42010-2022 elevates these practices to a unified organizational philosophy. It establishes an Architecture Description Framework, or ADF. This is a meta layer that ensures logical consistency across wildly different departments, allowing multiple legacy frameworks to coexist. The standard requires every architectural choice to be backed by a documented rationale. This forces architects to justify their decisions based on the specific viewpoints and stakeholder concerns defined in the framework. Look at this complex geometric structure restabilizing itself as it navigates a chaotic storm. The ability to document and evolve these invisible rules determines whether an enterprise can scale its technology without its communication structures collapsing under that growth.